So I've taken the liberty of slightly retitling from the title Rebecca gave me, How to Grow a 300-Year-Old Tree. And what I want to talk about particularly is the influence that our requirement, not just to grow trees, but to grow trees for a long time, has on the issues that have been so well expressed by our two speakers before. This is kind of what we do in woodland conservation. And I'm going to start with the idea that a central objective is that we want to grow old trees. We want to grow native trees that run through their natural life till they become big and old and senesce and die and turn into large lumps of dead wood. In order, given that objective, what we do is this. We start to grow locally native trees, we plant them, we regenerate them, and then we wait a long time. That's more or less forest conservation. It starts things off, and there are some management things involved, and there are some treatment elements, options that we have as well. But essentially, what we're doing is trying to grow trees so that we consistently have big old trees, big old locally native trees in our conservation woodlands, in our native woodlands. And very noddy kind of image there. What I suggest where I suggest we are now is that that model might not work anymore. That we still have this objective, we still want to grow big old native trees, but we're not at all sure that planting them, regenerating them now and waiting for a long time, we're not at all sure that that will give us that outcome. And again, fairly crudely, but this succession can end somewhere like this, which is a 170-year-old oak wood in central France that has died from a series of probably climate change-induced droughts. So that's really what I want to put to you, and we'll see where we get to with that. A little bit more about big old trees. We like big old trees, and all the way through this, I've decided to use quite a lot of quotes from the literature, because what I'm trying to indicate is that this is not just a few people's perspective. It's not SNH's perspective, it's not SNH's policy, but it's coming very strongly through the literature, through the research. And we get phrases like this from my friend Jim Lutz at Utah State University. Large diameter trees dominate the dynamics, the structure and the function, the scientific and social interest, and contribute disproportionately when they die. And then Robert Reeb, who's done a lot of landscape and social preference studies about forests and trees. There's a lot of work that says clearly people like big trees. They like big old trees. And then under-researched medical possibilities from Spike Milligan there as well, a sure cure for seasickness. But a picture's much more fun. This is about, I don't know, it's a 300-year-old probably oak tree, and it's got dead wood in the canopy, and you can see that's broken off, so there's a big lump of dead wood on the ground. It's got a cavity, and big holes in trees are most wonderful ecosystems in their own right. Bats, birds, other mammals, a whole range of insect species live only in these places, and a whole range of smaller stuff as well. The complexity of the crown, maybe it doesn't come out too clearly, but you have wetter areas. So you can see this moss grows down in the wetter areas where the water collects. You've got different species of epiphytes growing under the branches compared to on top of the branches in the sunshine. And it's this kind of tree, not wall to wall, clearly. You have to have a succession of younger trees coming through. But this is what has a great deal of the interest and the value and the wonder and what we appreciate about native woodlands, about conservation woodlands, is these kind of trees. That has some big implications. Those hundreds of years that we need to grow one of those trees. And there's three big implications that I wanted to take you through. The first one is, clearly, if something is growing for 200 years, 300 years, I liked Hugh's phrase, it has to be lucky every year. And we are having a competition to see who can mention each other's name most, so I shall try not to mention him again. But for those 200 years, for those 300 years, the tree has to survive everything that is thrown at it. And we are expecting things to change. We are expecting different environments for growing trees, different impacts from climate change, both in terms of average, in terms of mean temperature, mean precipitation, but also the extremes and the wild weather, and the consequences for pests and pathogens. So we'll touch on that, because they all have consequences on tree health. And if a tree is sick or it dies, then we don't get the big old trees. So that's where that equation that I started with starts to come unstuck. Now, again, you've seen this, so I won't dwell on this, other than this is a completely separate paper that reinforces what Hugh showed you. Again, we have this big upward sweep of problems, and in particular in the last 30 years coming from Asia, but also coming as new hybrid species. The Phytophthora that is affecting alder quite widely across Europe is not an introduced species, and it's not a native species. It's one that has hybridized and developed. It's a new one. That's part of the problem we've got. Very same pattern, that's the UK. You've seen that slide more or less already. And you've seen this slide already. So we'll keep on going through, other than to say, again, this is not an introduced species. We're not just worried about introduced species. This is a native species in its native range, where climate change has allowed better insect survival and more generations. It's jumped the Rockies, it's heading east across Canada. It is potentially a global impact, not just a global forest impact, but a global impact in terms of its climate effect. Dothystroma, we've seen a number of slides from that already. Again, that has been a relatively blameless resident of our pine woods for the last 80 years or so. Probably it's linked again to climate change. So the interaction between climate change and pests and pathogens is really important. Climate, again, we've seen some of this before. Climate is going to do some strange things. That's the prediction, 3 to 4 degrees by 2080. We've had, as we've seen, about 1 degree so far. That's on the high emissions track, but that's the track we're on. That's a reasonable expectation from where we are now. And 3 or 4 degrees average, with everything that goes with that, in terms of its effects and its extreme weather, is an enormous assault on the status quo, the environment that our trees, our native trees, have been used to. Lots of words here, but they're good ones. And it's clearly, these pieces of work saying clearly that climate affects the forest through disturbance regimes, through storms, insects, pathogens, droughts, waterlogging, and pathogens are able to adapt faster. And you can expect, as we've seen with the mountain pine beetle, accelerated development, lower mortality rates, mass outbreaks, range expansions and range shifts. So the interaction over the next 200 years, 300 years, is very hard to predict in detail, but it seems to me that there's a clear message there that we should expect this kind of change, these external drivers of change, to have a really strong influence on tree health over that time scale. So the second implication is that the steps we can take need to cover a long time. We need to grow a tree that's not just resilient to what we expect in a year's time, or 10 years' time, or 50 years' time. We need to take a decision about a tree, a genotype, a species, a mixture that we think will be viable for several centuries. The adaptation measures and approaches that we have kind of already agreed to tend to be in the no regrets category. They're fairly limited. They talk a lot about we should get our woods into good condition. We should have connectivity, better connectivity to allow species to move and adapt within their range to find sites that are suitable for them. We can't test these. We can't target them either when we have to look 200 years ahead. And I have enormous respect for the work that JHI have done, but to roll that forward for a couple of centuries when we don't know very much about what's going to happen, other than it's going to be quite different, that seems to be a really tough, really hard thing to do. And I think those no regrets approaches to resilience are probably going to be not good enough. Ash dieback. I knew you'd want me to talk about this, so I'll touch on it briefly. If we fix the problems that come from ash dieback, whether we fix them by finding a resistant strain, finding some measure that defeats Callara somehow, that's dealing with today's problem. Tomorrow's problem is this guy, the emerald ash borer, currently heading west from Moscow at 40 miles a year, where it's well established. That'll be with us by the end of the careers of some of us in this room and by the dotage and senility of others of us. And that's just what we can see. That's the near-term stuff. What pressures, what damaging agents are going to come in 150 years' time? That's the question that also needs answering, as well as what do we do with today's problems. Another example, just briefly, of why the modest adaptation measures we've talked about probably aren't good enough, and this is from some work by Sally Aitken, who's very highly respected in this field in Vancouver, looking at the degree to which we could expect trees to use connectivity to move, to change their ranges to more suitable conditions. And the numbers are there. 1,000 metres a year is probably in the order, plus or minus, of what tree species should move to stay in the same climate. After the last ice age, we think they moved less than 100 metres a year, and the models, again, this is in the US, of what they might move now are in the same order, 100, 200 metres a year. So connectivity is probably terribly important for things that flutter and things that fly and things that crawl and things that have reasonable dispersion. But it's probably not good enough for trees. The third implication that I want to look at that comes from this multi-century timescale is that we can't wait until we know what the future is. We can't wait until uncertainty diminishes. It takes a long time to grow the things we want to grow. We can't just sit on our hands for 100 years and wait till we understand what the issues are going to be in 100 years' time. That is, if we wait until we know what the problems are, it will be too late to act. And this is a great quote from Marcus Lindner at the European Forestry Institute in Finland. Inherent uncertainties are unavoidable. Waiting for improved evidence and information cannot be the solution. Decision makers in forest management have to realise they must take long-lasting management decisions while uncertainty about climate change impacts are still large. That's where we are. We aren't going to be able to be sure before we have to take these decisions. So what do we do? Well, we've heard some of the answers already, and so you'll pick up some of the same themes coming through, which is perhaps a good thing. Diversity seems to be an essential component. I don't think we can get away from that. I think there is a range of other things that we can do, some of the approaches we've talked about. We can think about treatments, we can think about site management, but in the end, there's so much uncertainty. The only response that we've been able to come up with to have to make a decision, don't know, can't tell what the right answer is don't put all your eggs in one basket. And these two sites are very interesting. They're semi-natural woodland, they're highly valued. We've already heard about Rassel. In this picture, Allerdale, those pines, that's the only species there. There's one species of tree, and they're all probably fairly closely related. That's a Natura site. That's a terribly important native woodland. but it's also terribly fragile, terribly low diversity. If Dothystroma starts to have an impact, or some other pest, pathogen, or climate impact starts to have an impact, there's nothing else there that has that function of those trees. Again, Rassel. Rassel is pretty much ash and hazel. And while the hazel can do some of the things that the ash can do, it can't do a lot of things, and it certainly doesn't have the landscape presence that those big ash trees have. So, again, it's not just plantations that are low diversity, and it's not just plantations that are vulnerable. If we're going to talk about diversity, and I keep coming back to the idea, the earlier speakers were talking more broadly about tree species and tree species choice than woodland conservation does. Woodland conservation has a template. If you want to know what it really is, it's called Bulletin 1112, published by the Forestry Commission in 1994. But it basically says, this is what's right. This is the way we should do things. These are the kinds of places you find these mixtures of trees, and those trees have to be, as the bottom one says, from well-matched sites in the locality. And forest conservation has this approach that says there is an answer. We know what the answer is. There is a template. Do this. And the language is kind of singular. The UK Forestry Standard, the right tree in the right place, SNH's best practice guidance. Do we know what's best? I certainly don't. We have common standards. Our designated sites are managed to generic targets for site condition monitoring. We have imposed a uniformity across this, which creates a risk in itself. I've talked about greater species diversity. The tree species, the trees are the heart of this. They're the thing that takes so long to grow and replace. So we probably need to break out of the suite of native species, the Bulletin 112, only these are allowed. Non-local genotypes, oak from southern England. Again, we've heard about Duncan Ray and some of the work he's done, and he's talked about this. Replacement species. We're kind of losing elm. We're probably going to lose ash. Now is the time to find some replacements for them, whether it's sycamore, whether it's lime, whether it's something else, whether it's oak. Oak has many benefits, but it also is threatened itself. Should we be relying on oak? Or is that, again, too risky? And the time scale means that if we're going to do something, we should do it now. If we wait until we know we have a problem, it's too late. I keep coming back to this. We can use analog species. They don't have to be native. They can be alternatives. I'm no lichen expert, but this is just a rather nice picture, a characteristic species of the Celtic rainforest growing on sycamore. Another example is in Abernethy, in the pinewood. RSPB felled the big Norway spruce that were through there, and those Norway spruce are now terribly important for this other Natura species, green shield moss, Buxbaumia viridis. It's not the case that only native species count. It's not the case that only native species do the things we want in conservation. Is there a lot of complexity there? Yep. Is there a lot to unpack? Absolutely. But clearly, I don't believe we can start from a position that says native is the only show in town. It would also mean not doing something. And a range of our uncertainty also includes that we might be wrong. We might not have climate change on the rate and scale that we think we are going to. And we might have really effective biosecurity controls. So some of the things that Hugh was saying, maybe, we at least need to have in mind the possibility that the outcomes may not be as bad as we think they might. So we have some reference sites. We have some places where we don't do anything. We just leave it and see what happens. This is a hot topic. This is being discussed very intensively between government agencies and with the research people. And I only came in just as this meeting was starting because I was at a separate meeting with almost exactly the same agenda from the Royal Scottish Forestry Society and the Institute of Chartered Foresters, because I think people get that we have to start thinking differently. We can't just use the paradigms that we've inherited. So we are talking. There's a lot of talking going on, and it's great that the Landscape Institute is taking that on as well. There probably isn't any final answer. I think we're going to be thinking the best we can do is this is what we should do now, and in another 5 years or another 10 years, we'll maybe be thinking, right, we should do something different. And that may be continually changing. So again, Bulletin 112 unchanged for the last 20 years. I don't think we're going to be doing that again. The world's changing too fast, and our understanding and our appreciation of the risks is changing too fast. Risk-based approaches, we can't assume certainty. We simply can't say, if you do this, you're definitely going to get that. That's in the context of growing big old trees for hundreds of years. It's completely unjustified now. And I thought I put these in monocultures of heather. Hugh stole that and even showed you a picture, but I'll add you another one. Sphagnum. Our blanket bogs are sphagnum bogs, largely, and with between 1 and 3 degrees of warming from the baseline, sphagnum loses its competitive edge against flowering plants. So sphagnum, blanket bogs, the big peatlands in the north, these icons of conservation, there's some really interesting and difficult questions about that. About, for example, the millions of pounds we're currently investing to bring them into good condition, because in another 40, 50 years, they might be irretrievably changed. George Peterkin gets the credit for starting to think about this. He talked about future native long ago. But we've tended to treat native as a spatial thing. We've tended to say native means native to a place. And there's a really interesting developing field of temporal ecology, in contrast to spatial ecology. It's saying let's think about time and how that affects things. So if something is native to a place, then maybe we ought to start thinking about it being native to a time as well as a place. Because that starts to allow us to accept that things can't just stay the same when the outside world is changing around us. So I'll stop with that thought. Thank you.